Okay, good morning, my dear students. In previous class, we discussed about some properties of periodic table. Okay, that is van der Waals radius, covalent radius, and other one is ionic radius. Right? So now this class or this session we discuss about remaining properties of periodic table, right? The another property is atomic size. Right? It's very important. Okay, see what happens along the period or down the groove. Along the period means the horizontal rows are called as periods, and down the columns, vertical columns are called as groups. See what happens. Atomic size ಏನಾಗುತ್ತೆ ಅನ್ನೋದು important. Along the period and down the group. See, let us consider the third period. Right? See, the first shell, the second shell, the third shell. Okay, third period means having three shells. Okay, this is the nucleus. First shell, second shell, third shell. K shell, L shell, and M shell. See here, in this cell, for example, in third period it is the center of the nucleus. See, this is the outermost shell. Is it clear? Here, outermost shell is a M shell. See, atomic size or atomic radius. See, compared to this center of nucleus and we initially compare one. See what happens along the period, right? See, we know that when the size is small, the force of attraction in between nucleus and electron is more. See, ಇದನ್ನ ನಾವು ಏನಾದರೂ ನ್ಯೂಕ್ಲಿಯಸ್ ಅಂತ ತಗೊಂಡ್ರೆ, ಇದು ನಾವು ಎಲೆಕ್ಟ್ರಾನ್ ಅಂತ ತಗೊಂಡ್ರೆ, ಸೈಜ್ ಏನಾದರೂ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋದ್ರೆ the force of attraction is high in between nucleus and electron, right? See, in this period, here nucleus, this is almost electron. The force of attraction is high, right? And another example, we move on to only for along the period. Next, atom. See, okay, this is nucleus, this is almost electron. Here, one proton, one electron is increases. Next, we move on to third or second atom for along the period. Here also one more proton and one more electron is increases. See what happens? See, one more proton or one more electron is increases along the period. So what happens? The effective nuclear charge is increases. Already in previous class, I told you effective nuclear charge means the number of protons present in it. That is the effective nuclear charge. ಇಲ್ಲಿ ಇದು ಕಾಂಪಿಟೇಷನ್ ನಾವು ಮಾಡ್ತಾ ಹೋದ್ರೆ ಅಗೇನ್ ಇಲ್ಲಿ ಒಂದು ಪ್ರೋಟಾನ್ ಇದೆ, ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆ. ಅಗೇನ್ ಇದರಿಂದ ಮತ್ತೆ ಏನು ಮಾಡ್ತು, ಅಗೇನ್ one proton and one electron increases ಆಯ್ತು, add ಆಯ್ತು. So what happens? The effective nuclear charge is increases. Okay, ಇಲ್ಲಿ outermost shell ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಇರ್ತವೆ, ಇಲ್ಲಿ ಪ್ರೋಟಾನ್ ಕೂಡ ಅಡಿಷನ್ ಆಗೋದ್ರಿಂದ the force of attraction is more ಅಲ್ವಾ, ಪಾಸಿಟಿವ್ ಅಂದ್ರೆ ಪ್ರೋಟಾನ್ ಇದೆ, ಹಾಗೆ ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆ, ಆಡ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. The force of attraction is high. That's why this atomic radius is decreases. Atomic radius is decreases. Is it clear? Or atomic size is decreases. See, compared to these two atoms, right? Iveredu atoms compare ಮಾಡಿದ್ರೆ its force of attraction is high compared to this atom, because here again one more proton, one more electron is present in it. One more proton or one more electron present ಇರೋದ್ರಿಂದ here nuclear force of proton ಏನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋದಂತೆ here force of attraction in between nucleus and electron is more ಇರೋದ್ರಿಂದ this atomic size is decreases. Next we move on to another atom. See, first shell, this is second shell, this is third shell. Okay, this is nucleus, okay, this is outermost electron. Here again one more proton and one more electron is increases. One more proton or one more electron is increases. Again this force of attraction in between nucleus and outermost electron is high ಇರುತ್ತೆ. ಹಾಗಾಗಿ ಏನಾಗುತ್ತೆ, automatically this atomic size is decreases. Okay, these are the along the period. Okay, ನೋಡಿ ಫಸ್ಟ್ ಆಟಮಿಕ್ ಕಂಪೇರ್ ಮಾಡ್ಕೊಳ್ಳೋಣ, ಸೆಕೆಂಡ್ ಆಟಮಿಕ್ ಕಂಪೇರ್ ಮಾಡ್ಕೊಳ್ಳೋಣ ಅಂಡ್ ಥರ್ಡ್ ಆಟಮಿಗೆ ಕಂಪೇರ್ ಮಾಡ್ತಾ ಹೋಗ್ತಿದೀವಿ. ಓಕೆ, ಇದರ ಆಟಮಿಕ್ ಸೈಜ್ ಕಡಿಮೆ ಇದೆ, ಇದಕ್ಕೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಆಟಮಿಕ್ ಸೈಜ್ ಜಾಸ್ತಿ ಇದೆ, ಇದಕ್ಕೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಆಟಮಿಕ್ ಸೈಜ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. See, from along the period ನೋಡ್ತಾ ಹೋದ್ರೆ this atomic size is low, here less, here the compare it is also very less. Okay, it means that, see what happens in along the period, this atomic size is increases, decreases the along the period, right? So ಯಾಕೆ decrease ಆಯಿತು, with increases the effective nuclear charge, that is very important. Increases the effective nuclear charge. Effective nuclear charge means the number of protons are present in it. So that effective nuclear charge increase ಆಗೋದ್ರಿಂದ the force of attraction in between the nucleus and outermost electron is high. That's why its atomic radius is slightly decreases. That is very important, right? That is along the period. Next we move on to down the groove ನೋಡೋಣ. Right. This is fourth period. Okay. For example, we can take this is the 3 picometer, and then it is 2.5 picometer. It is 2.8 picometer. Right. Its atomic size is decreases the along the period because with increasing number of protons means increase the nuclear force of attraction in between electron and nucleus, right? See, this is fourth period. The fourth period having 4 picometer or picometer. See what happens? See, already I told you. See, compare to third period and fourth period again. Now we discuss about the down the groove, right? This is the nucleus, right? It is the outermost electron, the valence shell, right? Valence shell is the outermost electron. See, compare to third period atom and fourth period atom compare ಮಾಡ್ಕೊಂಡ್ರೆ its atomic size ನೋಡ್ತಾ ಹೋದ್ರೆ ಏನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಇದೆ ಅಂತ ಅನ್ಸುತ್ತಲ್ವಾ? ಜಾಸ್ತಿ ಇದೆ ಅಂತ ಅನ್ಸುತ್ತೆ. ಸಿ ಥರ್ಡ್ period ಕಂಪೇರ್ ಮಾಡ್ಕೊಂಡು, ರೈಟ್? ಸಿ ಯಾಕೆ ಅಂತಂದ್ರೆ the atomic size is increases. Is it clear? The atomic size ಇದಕ್ಕೆ ನಾವು ಕಂಪೇರ್ ಮಾಡ್ತಿದೀವಿ. This atomic size is increases in the down the groove because with increases in the number of shells, right? Here in third period having 3 shells, 1 2 3, right? 1 2 3, okay. But here in fourth period ಅಲ್ಲಿ atomic size will be 4 cells. This 1 2 3 4. ಯಾಕೆ increases ಆಗುತ್ತೆ atomic size in the down the groove ಅಂತಂದ್ರೆ because with increases the number of shells increases ಆಗೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ, the force of attraction in between nucleus and outermost electron is less. So the effective nuclear charge ಏನಾಗುತ್ತೆ, it is also decreases. Effective nuclear charge is decreases. This the atomic size will be increases. So the force of attraction in between nucleus and outermost electron is decreases ಆಗೋದ್ರಿಂದ ಯಾಕೆಂದ್ರೆ ನಂಬರ್ ಆಫ್ ಶೆಲ್ಸ್ ಅಲ್ಲಿ ಥರ್ಡ್ ಶೆಲ್ಸ್ ಅಲ್ಲಿ ಟೋಟಲಿ 18 ಎಲೆಕ್ಟ್ರಾನ್ ಇರುತ್ತೆ. ಅಗೇನ್ ಫೋರ್ತ್ ಶೆಲ್ಸ್ ಟೋಟಲಿ 32 ಎಲೆಕ್ಟ್ರಾನ್ ಆಗುತ್ತೆ. 32 ಎಲೆಕ್ಟ್ರಾನ್ ಆಗೋದ್ರಿಂದ ನಂಬರ್ ಆಫ್ ಶೆಲ್ಸ್ ಇನ್ಕ್ರೀಸಸ್ ಆಗ್ತಾ ಹೋದ್ರೆ ಹಿಯರ್ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಅಡಿಷನ್ ಆಗ್ತಾ ಹೋದ್ರು. ಅಡಿಷನ್ ಆಗೋದ್ರಿಂದ ಹಿಯರ್ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಸಿ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಏನಾಯ್ತು, ಅಡಿಷನ್ ಆಗ್ತಾ ಹೋಯ್ತು ಅಲ್ವಾ? ಈ ತರ ಹೋದ್ರೆ ಸಿ ಒನ್ ಎಲೆಕ್ಟ್ರಾನ್ ಅಂಡ್ ಅನದರ್ ಎಲೆಕ್ಟ್ರಾನ್ ಏನಾಯ್ತು, ರಿಪಲ್ಷನ್ ಟು ಈಚ್ ಅದರ್ ಒಂದಕ್ಕೊಂದು ಏನಾಯ್ತು, ರಿಪಲ್ಷನ್ ಆಗೋದ್ರಿಂದ ಇಟ್ ಸೈಜ್ ಏನಾಗ್ತಾ ಹೋಯ್ತು, ಇನ್ಕ್ರೀಸಸ್ ಆಗ್ತಾ ಹೋಯ್ತು. ಅವಾಗ ಏನಾಯ್ತು, ಸೈಜ್ ಇನ್ಕ್ರೀಸಸ್ ಆಯ್ತು ಅಂತಂದ್ರೆ ಆಟೋಮಿಕ್ ರೇಡಿಯಸ್ ಏನಾಯ್ತು, ಜಾಸ್ತಿ ಆಯ್ತು ಹೋಯ್ತು. ಆಟೋಮಿಕ್ ರೇಡಿಯಸ್ ಜಾಸ್ತಿ ಆಗೋದ್ರಿಂದ the force of attraction in between nucleus and electron is very less ಆಗ್ತಕ್ಕಂಥದ್ದು ಬರುತ್ತೆ. Is it clear? Okay, this is about the atomic size. Is it clear? So what happens, the atomic size along the period and down the groove is, see, the atomic size decreases with increases the effective nuclear charge. Okay, it is along the period. Right? Very important. Next, what about down the groove? Right? The atomic size increases. Atomic size increases with increases the number of valence It's very big. Okay, see atomic size is decreases. Atomic size along the period ಏನಾಗ್ತಾ ಹೋಗ್ತಿದೆ, decreases ಆಗ್ತಿದೆ. Is it clear? ಯಾಕೆ decreases ಆಗ್ತಿದೆ? See number of protons or number of electron increases ಆಗುತ್ತೆ. here number force of attraction ಇಂದು ಏನಾಯ್ತು, ಜಾಸ್ತಿ ಆಯ್ತು in between nucleus and outermost electron. ಹಾಗಾಗಿ effective nuclear charge increases ಆಗೋದ್ರಿಂದ force of attraction is more. force of attraction ಜಾಸ್ತಿ ಆಗೋದ್ರಿಂದ ಅವಾಗ ಏನಾಯ್ತು, that atomic size slightly decreases, right? in atomic size in down the groove ನಾವು ನೋಡೋದಾದ್ರೆ is down the groove, right? down the groove. Okay, see atomic size. here atomic size is increases after. ಯಾಕೆ increases ಆಯ್ತು ಹೋಯ್ತು, with increase the number of shell. number of shells increases ಆಗೋದ್ರಿಂದ see force of attraction is very less in between nucleus and outermost electron. ಹಾಗಾಗಿ number of electron ಇರುತ್ತೆ, ಈ ಎಲೆಕ್ಟ್ರಾನ್ ಒಂದೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಜೊತೆಗೆ ಒಂದು ಶೆಲ್ ಇಂದ ಇನ್ನೊಂದು ಶೆಲ್ ಇರ್ತಕ್ಕಂಥ ಎಲೆಕ್ಟ್ರಾನ್ ಗೆ ರಿಪಲ್ಷನ್ ಆಗ್ತಾ ಹೋಯ್ತು. ರಿಪಲ್ಷನ್ ಆಗೋದ್ರಿಂದನೇ here this the atomic size is increases in the down the groove. Okay, dear students, it is the very important properties of the periodic table, right? next we move on to isoelectronic species. Isoelectronic species. Isoelectronic species. See, iso means same number. It is 2 marks question, very important point of view on your examination. ತುಂಬಾ ಸರಿ ರಿಪೀಟ್ ಆಗಿರತಕ್ಕಂತ ಕ್ವೆಶ್ಚನ್ ಅಂದ್ರೆ this one. See what are isoelectronic species? Give an example ಅಂತ ಕೇಳ್ತಾರೆ. 2 marks ಕೇಳ್ತಕ್ಕಂತ ಕ್ವೆಶ್ಚನ್, right? See this one, iso implies that iso means same. Iso means same, right? Say isoelectronic species means different species having same number of electrons. That is called as isoelectronic species. Iso means same, electronic means electron, species means different species. Different ಬೇರೆ species ಗಳು ಒಂದೇ ತರಹದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ಹೊಂದಿರತಕ್ಕಂತವಕ್ಕೆ ಎಂತ ಕರಿತೀವಿ, ಐಸೋ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಸ್ಪೀಸೀಸ್ ಅಂತ ಕರಿತೀವಿ. See, isoelectronic species means different species having same number of electrons. Same number of electrons are called isoelectronic species. Isoelectronic species. Is it clear? The different species having same number of electrons are called isoelectronic species, isoelectronic species. See, firstly, consider the, for example, see elements, right? See, first one is nitrogen. This nitrogen carries 3 electrons, right? Next, oxygen. This oxygen gains 2 electrons. Next, fluorine. This fluorine, it gains only 1 electron. Next, Na. Na means sodium. This sodium is donates 1 electron, right? Next, Mg. Mg means magnesium, right? This magnesium is donates 2 electron. Okay. Next, aluminium. Okay. See, this aluminium which donates 3 electron. 3 electron. Is it clear? This nitrogen, it gains 3 electron. This negative charge indicates the gain of electron. Gain of electron. Right? See, for example, ನನ್ನ ಹತ್ರ 10 rupees ಇದೆ ಅಂತಂದ್ರೆ ನಾನೇನ್ ಮಾಡ್ತೀನಿ, ಅದರ್ ಪರ್ಸನ್ ಇಂದ ಅಗೇನ್ 10 rupees ನ ಇಸ್ಕೊಳ್ತೀನಿ. ದಟ್ ಈಸ್ ಗೇನಿಂಗ್. ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ನನ್ನ ಹತ್ರ ಎಷ್ಟಾಯ್ತು rupees? 20 rupees ಆಯ್ತು. ದಟ್ ಈಸ್ ರೈಟ್. ಸಿ, ಅಂಡ್ ದಿಸ್ ಆಕ್ಸಿಜನ್, ದಿಸ್ ನೈಟ್ರೋಜನ್ 3 rupees ನ ಗೇನ್ ಮಾಡ್ಕೊಳ್ತು, ಆಕ್ಸಿಜನ್ 2 rupees ನ ಗೇನ್ ಮಾಡ್ಕೊಂತು, ಫ್ಲೂರಿನ್ ಏನ್ ಮಾಡ್ತು 1 rupee ನ ಗೇನ್ ಮಾಡ್ಕೊಂತು. rupees means here electrons, right? This sodium which donates 1 rupee, 1 rupee donate ಮಾಡಿದ್ರು. 1 rupee means 1 electron. This positive charge is represents the which donates the electron, right? See how many electron it donates? Total only 1 electron. In magnesium is total 2 electron donate ಮಾಡಿದೆ. This aluminium 3 electron donate ಮಾಡಿದೆ. Is it clear? Okay. See, next, the number of electrons. The number of electrons is, see, nitrogen is 7 plus 3 is 10 electron, right? Next, come to oxygen. Oxygen has 8 electron. This oxygen, it gives another 2 electron. That's what 8 plus 2 is 10 electron. Is it clear? Next, we move on to fluorine atom. Fluorine atom in bandre, very simple. This fluorine has 9 electron. It gives other 1 electron. 1 electron ಮತ್ತೆ ಪುನಃ ಏನು ಮಾಡ್ತಾರೆ, gain ಮಾಡ್ತಾರೆ ಅಲ್ವಾ? See, total 9 plus 1 is total 10 electron. See, next, sodium. This sodium has total 11 electron. 11 electron only which donates only 1 electron. 10 minus 1 is total 10 electron. This magnesium has total 12 electron. This donates the 2 electron. The total number of electron 10 minus 12 minus 2 is 10 electron. We have come to the last one element is aluminium. This aluminium has total 13 electron, right? This 13 electron is donates the 3 electron. This 13 minus 3 is total 10 electron. Is it clear? Next we move on to nuclear force or nuclear charge. Right? See here, the nuclear charge. Nuclear charge number of protons, right? In nitrogen has total number of protons is 7, oxygen is 8, fluorine is 9, sodium is 11, magnesium is 12, aluminum is 13. Right? Next, radius. In angstrom. Angstrom means what? Angstrom is, that is the 10 to the power of minus 10, right? That is the angstrom. 1 angstrom andre 10 to the power of minus 10. Okay, its radius is atomic radius is this nitrogen is 1.7, right? In oxygen is 1.41, in fluorine is 1.36, sodium is 0.95, magnesium is 0.65, aluminum is 0.50, right? See, okay, see this table, element, number of electrons, nuclear charge, radius, right? Here nitrogen, oxygen, fluorine, sodium, magnesium, aluminum. Here these are different species. Is it clear? See how isoelectronic species having same number of electrons. See this table, nitrogen, oxygen, fluorine, sodium, magnesium, aluminum, all are different species, right? Here each species having same number of electrons. How many number of electrons? 10, 10, 10, like that. Is it clear? See the nuclear charge is also different. 7, 8, 9, 11, 12, 13. Is it clear? See, it is very important. The radius is what? This is the along the period, right? See 1.7, 1.41, 1.36, 0.95, 0.65 and 0.60. Here, this nitro, sodium to aluminum are positive species, right? And remaining these nitrogen to fluorine or negative species. See what are the difference between these two? See, with sodium it donates positive charge. It means that an effective nuclear charge. Is it clear? Effective nuclear charge means due to the presence of protons, right? See, here plus 2 plus 3, right? Plus 1 plus 2 plus 3. This effective nuclear charge is increases. Is it clear? I understand. Effective nuclear charge increases and when effective nuclear charge is increases, right? The force of attraction is very high. Very high. This radius, the atomic radius is decreases, right? See 0.95 to 0.61, 0.65 ಏನಾಗಿದೆ 0.50 ಬಂದಿದೆ. Is it clear? ಅಂದ್ರೆ this effective nuclear charge ಏನಾದರೂ increases ಆಗ್ತಾ ಹೋದ್ರೆ this atomic radius is decreases, right? This is the very important point of view. Is it clear? Next, see nitrogen, oxygen and fluorine. Nitrogen, oxygen and fluorine. See what happens here? In this case, positive charge increases agilla, but see additions of electron agide alva. Additions of electron agide, right? See 1 electron, 2 electron. ಅಡಿಷನ್ ಆಗಿದೆ, ಬಟ್ ಇಲ್ಲಿ 3 ಎಲೆಕ್ಟ್ರಾನ್ ಅಡಿಷನ್ ಆಗಿದೆ. ಸಿ ಸಪೋಸ್ ಇನ್ ಕೇಸ್ ಆಫ್ ವೆನ್ ಅಡಿಷನ್ ಆಫ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ ಆಗ್ತಾ ಹೋದ್ರೆ ಮೀನ್ಸ್ ಶೆಲ್ಸ್ ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಇನ್ಕ್ರೀಸಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಇನ್ಕ್ರೀಸಸ್ ಆಗೋದ್ರಿಂದ ಏನಾಯ್ತು, ದ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ in between nucleus and outermost electron is less ಆಗೋದ್ರಿಂದ one electron ಗೆ another electron ಗೆ repulsion to each other, ಒಂದಕ್ಕೊಂದು ಏನಾಗುತ್ತೆ, ರಿಪಲ್ಷನ್ ಆಗುತ್ತೆ. ರಿಪಲ್ಷನ್ ಆಗೋದ್ರಿಂದ its atomic radius ಯೂಶುವಲಿ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಇನ್ಕ್ರೀಸಸ್ ಆಗುತ್ತೆ. see here 1.36 to 1.41 ಬಂದಿದೆ, again 1.41 to 1.7 ಬಂದಿದೆ. means number of electrons ಏನಾಯ್ತು, increases ಆಗುತ್ತೆ. this effective nuclear charge is decreases. when effective nuclear charge is decreases, the force of attraction in between nucleus and outermost electron is decreases. That's why this atomic radius is increases, right? It is very important point of your examination. Is it clear? See, what are isoelectronic species, right? It is very important. Different species having the same number of electrons, that is called as isoelectronic species. Is it clear? This is about the isoelectronic species, right? Next we move on to ionization enthalpy. Ionization energy or ionization enthalpy or ionization potential, right? See, ionization energy ಅನ್ನೋದೇ, ionization enthalpy ಅನ್ನೋದೇ, ionization potential ಇದ್ರೂ ಕೂಡ, right? Ionization energy, ionization enthalpy or ionization potential. These different terms are represented by IE. IE means ionization enthalpy, or IP. IP means ionization potential, right? It is very important properties, right? So what is ionization energy or ionization potential or ionization enthalpy? ಏನು ಐನೇಷನ್ ಎಂಥಾಲ್ಪಿ ಅಂತ ಏನು, ಪೊಟೆನ್ಷಿಯಲ್ ಅಂದ್ರೆ ಏನು, ಆರ್ ಎಂಥಾಲ್ಪಿ ಅಂದ್ರೆ ಏನು ಅಂತ ಇಂಪಾರ್ಟೆಂಟ್, ರೈಟ್? ಸಿ right, it is one atom, this is nucleus, this is the outermost electron, potential electron, right? See, ನಾವೇನು ಮಾಡೋಣ, ಈ ಎಲೆಕ್ಟ್ರಾನ್ ನ ರಿಮೂವ್ ಮಾಡಬೇಕು. ಈ ಎಲೆಕ್ಟ್ರಾನ್ ನ ರಿಮೂವ್ ಮಾಡಬೇಕಂದ್ರೆ ಈಸಿಯಾಗಿ ರಿಮೂವ್ ಆಗಲ್ಲ, ಯಾಕಂದ್ರೆ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಬಿಡ್ವಿ, ನ್ಯೂಕ್ಲಿಯಸ್ ಅಂಡ್ ಔಟರ್ಮೋಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ ಗೆ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಇರುತ್ತೆ. ತುಂಬಾ ಈಸಿಯಾಗಿ ಅದನ್ನ ನಾವು ರಿಮೂವ್ ಮಾಡಕ್ಕೆ ಆಗಲ್ಲ. ಹಾಗಾಗಿ ಏನು ಮಾಡಬೇಕು, ಸೊ ವಿ ಅಪ್ಲೈ ಸಮ್ ಎನರ್ಜಿ ನಾವೇನು ಮಾಡಬೇಕು, ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಓಕೆ, ಸಿ ದಿಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಈಸ್ ರಿಮೂವ್ಡ್. removing the energy or required or removed. This electron is removed or required. ಹೆಂಗೆ ನಾವು ರಿಮೂವ್ ಮಾಡಬೇಕು? To apply some energy. ಎನರ್ಜಿ ನಾವೇನ್ ಮಾಡಬೇಕು? ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಓಕೆ, ಎಲ್ಲಿಗೆ ಅಪ್ಲೈ ಮಾಡಬೇಕು? ಔಟರ್ ಮೋಸ್ಟ್ ವೇಲೆಂಟ್ ಶೆಲ್ ಇರ್ತಕ್ಕಂಥ ಎಲೆಕ್ಟ್ರಾನ್ ನಾವೇನ್ ಮಾಡಬೇಕು? ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಓಕೆ, ಯಾವ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಇರುತ್ತೆ ಅಂತಂದ್ರೆ ಈ ಆಟಮು ಗ್ಯಾಸಿಯಸ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಇರಬೇಕು. ಓಕೆ, ಕಂಡೀಷನ್ ಇದೆ ರೈಟ್. ಫಸ್ಟ್ ಕಂಡೀಷನ್ ಏನು? ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ನಾವು ರಿಮೂವ್ ಮಾಡಬೇಕಂದ್ರೆ ಎನರ್ಜಿನ ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿನ ಸಪ್ಲೈ ಮಾಡಬೇಕು. ಸಪ್ಲೈ ಮಾಡಿದ್ರೆ ಎನರ್ಜಿನ ರಿಮೂವ್ ಮಾಡ್ತೀವಿ. ಎಲ್ಲಿ ಸಪ್ಲೈ ಮಾಡ್ತೀವಿ? ದಿಸ್ ಔಟರ್ ಮೋಸ್ಟ್ ಶೆಲ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್. ಔಟರ್ ಮೋಸ್ಟ್ ಶೆಲ್ ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಎಲೆಕ್ಟ್ರಾನಿಗೆ ಎನರ್ಜಿನ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ. ಈ ಆಟಮ್ ಅಲ್ಲಿ ಔಟರ್ ಮೋಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ ಎಲ್ಲಿ ಇರಬೇಕು? ಇನ್ ಗ್ಯಾಸಿಯಸ್ ಆಟಮ್ ಆಗಿರಬೇಕು. ದಟ್ ಈಸ್ ದಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. So what is ionization enthalpy or ionization potential? It is the removal of electron, right? It is applying energy. Energy ನಾವು ಏನು ಮಾಡ್ತೀವಿ? ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ. Okay, so what is the ionization energy or enthalpy ಅಂತಂದ್ರೆ it is defined as the amount of energy required or removal, right? Required or removal of electron of valence shell in a gaseous atom. In a gaseous atom. Gaseous atom ನಲ್ಲಿರ್ತಕ್ಕಂಥ ಔಟರ್ ಮೋಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇರ್ತಕ್ಕಂಥ ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಮಾಡತಕ್ಕಂಥ ಒಂದು ಪ್ರೋಸೆಸ್ ಗೆ is called as ionization enthalpy or ionization potential or ionization energy ಅಂತ ಕರೀತಕ್ಕಂಥ ನಾವು ನೋಡ್ತೀವಿ ರೈಟ್. ಓಕೆ, see what happens along the period and down the groove. Okay, see for example, see here this sodium is basic ನಾವು ಹೇಳ್ತಾ ಹೋದ್ರೆ this sodium ನ ನಾವೇನ್ ಮಾಡೋಣ? ಎನರ್ಜಿನ ಸಪ್ಲೈ ಮಾಡೋಣ ರೈಟ್. this sodium ಗೆ ನಾವು ಎನರ್ಜಿ ನಾವೇನ್ ಮಾಡ್ತೀವಿ? ಸಪ್ಲೈ ಮಾಡ್ತೀವಿ. ಸಪ್ಲೈ ಮಾಡಿರ್ತಕ್ಕಂಥ ಏನಾಯ್ತು? the sodium ಇರತಕ್ಕಂಥ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ನಾವೇನ್ ಮಾಡ್ತೀವಿ? ರಿಮೂವ್ ಮಾಡಬೇಕಲ್ವಾ? so Na plus 1 electron ನಾವು ಈಸಿಯಾಗಿ ರಿಮೂವ್ ಮಾಡಿದ್ವಿ. that is process right. see we give some example for this one. elements along the period. next ionization enthalpy. okay, see lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and one more neon. Right? Its ionization enthalpy is 520. This is 520. This 899, and this is 801. This 1086, 1402. This 1314. Next 1681, and this is 2081. Okay, see compared to this is along the period no along the period ನಾವು ನೋಡ್ತಾ ಹೋದ್ರೆ ಏನಾಗುತ್ತೆ? see along the period. okay, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Its ionization energy is 520, 899, 801, 1086, 1402, 1314, 16, here 81 and 2081. See what happens? They along the period this table or represents the along the period ನಾವು ನೋಡ್ತಾ ಹೋದ್ರೆ this ionization enthalpy is increases. Ionization enthalpy or ionization energy is increases ಆಗ್ತಕ್ಕಂಥದ್ದು ಬರುತ್ತೆ, right? And this is period. And what about group? Down the group ನಾವು ನೋಡಿದ್ರೆ what about group, right? For example, here elements is here lithium, and then sodium, potassium, rubidium, and one more cesium, right? Its ionization enthalpy is, already we know that this lithium is 520, here 495 and 417 and 403 and 376. Okay, see here in down the group ನಾನು ನೋಡ್ತಾ ಹೋದ್ರೆ what happens? The ionization energy, lithium is 520, sodium is 495, potassium is 417, rubidium is 403, cesium is 376, right? See compared to this table ನಾವು ನೋಡ್ತಾ ಹೋದ್ರೆ this ionization enthalpy or ionization energy is decreases the down the groove ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ decreases ಆಗ್ತಕ್ಕಂಥದ್ದು ನಾವು ನೋಡ್ತೀವಿ, right? See, on the basis of this concept we discussed about the conclusion of the what happens ionization enthalpy or ionization energy along the period and groups, down the groups, right? See, ionization energy is 528, right? So what happens? Increases the along the period, right? And down the groove ನೋಡ್ತಾ ಹೋದ್ರೆ see what happens in down the groove this ionization energy is decreases the down the groove, right? This is very important point of your examination. Okay, dear students, this is about the ionization energy or ionization enthalpy or ionization potential. See, already we know that ionization energy is the energy is required to remove the electron in the valence shell ಇರತಕ್ಕಂತ electron remove ಮಾಡತಕ್ಕಂತದ್ದು. Okay, gaseous atom, that is called as ionization energy. Okay, so what happens along the period and down the groove? In along the period this ionization energy is increases ಆಗುತ್ತೆ, in down the groove ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ decreases ಆಗ್ತಕ್ಕಂಥದ್ದು ನಾವು ನೋಡ್ತೀವಿ. Okay, this is about the ionization energy and ionization potential for the periodic table. Okay, thank you.